Now, for our second lesson in Chapter 7, we looked at last time at increase and decrease in functions. And notice when a function increases and then when it decreases, what we get actually is a vertex at that point here. And that's actually what we're going to look at in this section. We're going to look at what's called a local maximum, which is this highest value here, and the local minimum, which is the lowest value here. Now, the reason we have to put the word local in there is this actually isn't the highest point on this graph. The point up here would be the highest point. And similarly down here, this isn't the lowest point on the graph. This is the lowest point on the graph. But it's the lowest point within this certain region of the graph. Now, actually, we're probably just going to say maximum and minimum when actually we mean local maximums and minimums. Now, I've drawn tangents in it here for a very specific reason. And what you should notice about both of these two things is they have a slope of 0 at that point. And we're going to use that fact to help us find out where they actually occur on the graph. Now, there is quite a bit of vocabulary to begin with, so we need to make sure we know exactly all the different phrases so we know exactly what we're finding. So other phrases that we might use are, we might use the phrase stationary points, stationary meaning not moving, so like the slope is 0. We also use the phrase turning points because the graph turns around, which is where the vertex is. And also in AP, they also use the phrase points of extrema. So in other words, extreme points, in other words, maximums and minimums again. So just be aware of all those different words of vocabulary as well. And just as a reminder, all of these have a slope of 0. So if we want to find something like that, then what that means is dy by dx, which is the slope, is equal to 0. So let's have a look at how we would apply that to a question. Well, we're also going to need one other key fact as well. And we're going to need to find out, once we've found something's a stationary point and has a slope of 0, is it a maximum or is it a minimum? And to use that, we actually use the second derivative. So when we write that, we either put f double dash of x to show that it's the second derivative, or we put d2y over dx2 with the number once again showing what the derivative is. So to find this, all we do is we differentiate our first differential, in other words dy by dx, or for this one, f dash of x. And then there's two possible cases we're interested in. If this second derivative is greater than 0, then we have a minimum. And if the second derivative is less than 0, then we have a maximum. And there is a third case as well. What happens if it equals 0? And we'll address that in a later section. Now, for today's lesson, actually, all we're going to do is we're going to focus on quadratics. So for x squared, as it's positive x squared, this is a nice U shape. So we actually already know that this one's going to be a minimum. And actually, we also know a method for finding this as well. So I could complete the square on this question. So half the coefficient of -8 is -4, and then square it. And then I know from this I'm going to get the first two terms here, but not the last term. So -4 squared is 16, but I only just want 4. So if I take away 12, 16 take away 12 would give me 4. And then once it's written in this form here, then I can actually say what the vertex is. So do the opposite of the first number, and the second number should be the same. So that should be -12 there. And as we know the graph is U-shaped, as we said before, then we can actually say this is a minimum at 4, -12. But we're going to do this question by calculus, so we're going to do something slightly different here. So we're going to use the fact that slopes occur when dy by dx equals 0. So we're going to differentiate this equation, as you can see here, and then set it equal to 0. And then we're going to solve that equation. So when does 2x minus 8 equal 0? Clearly when x equals 4. And then we've got some other information we need to find. We need to find out what the y value is. So if we plug 4 back into this equation up here, which we can just see, 4 squared minus 8 times 4 plus 4, then we should end up with -12, just like we did here, of course, because it's the same question. And we also need to find out what that second derivative is as well, to find out if this is a maximum or a minimum. So we need to differentiate this. So if we differentiate 2x minus 8, then we end up with 2. As 2 is a positive number, in other words it's greater than 0, we can actually say that it's a minimum for that point. So for the questions we're going to look at today, these are all quadratics. We can actually check by completing the square, and you're actually asked to do that. But we can also do this by calculations and calculus by differentiating this expression, plugging in our x value into the second derivative and checking if it's greater than 0, we're going to say it's a minimum, and if it's less than 0, it's a maximum. And once again, if we get equal to 0, we're going to leave that for the time being.